Hey, what's going on, guys? Let's look at this problem right here. Here this question is asking, write behavioral VHDL models for the following 4-bit counter shown in figure 4.8. Here we have a 4-bit counter. We have enabled load and clock clear and QDCO. Okay, now let's go ahead and write our VHDL code. First, here we are going to use std logic, so we have to import library IEEE, then after that we are going to use IEEE .std underscore logic underscore 1164.all, and after that we are going to create the entity should be usually the given name. Here 4-bit counter, that's the name I'm going to give for the entity. 4-bit counter is, and port, here's where we put the input and output. Now here you can see clock is input and clear is input, E is input, and also we have load and other things. Let's write this one down. Clock, clear, E, all of them are input, std underscore logic, and after that we have a Q output. So I put Q out std underscore logic underscore vector, and this is a 4-bit output, so 3 down to 0. Then after that CO is an output, so CO out std logic, and that's all we need for the 4-bit counter. Okay, so let's end this one. End 4-bit counter. Now the next thing is we have to introduce architecture, and here behavioral of the same name given to entity should be given right here. This is behavioral of 4-bit counter is signal count that is std underscore logic underscore vector, that's 4-bit, so 3 down to 0. Then begin process clock comma clear begin, then if clear is equal to 1, if clear is equal to if clear is equal to 1, then here if the clear is equal to 1 regardless of whatever other it is, because all of them are don't care, so it's going to be the same thing, then clear counter, it means clear is going to be 0, count is going to be 0. Okay, so then we can say count is going to be 0, but since this is a 4-bit counter we had to put 40. Okay, now let's continue the code right here. So this is the first condition. If the clear is 1, then clear counter. Now let's go to the next one. So we can, the next one is else if I use a different color to avoid confusions. Else if clock event and clock is equal to 1, then if LD load is equal to 1, then here you can see else if mean clear is 0, because if clear is 1, it's going to go to directly to this one and print this is going to be the output. But if the clear is not equal to 1, 0, then it's going to the next one, else if. In the else if the load is equal to 1, then load D input into counter. So the D will be go to the counter. So the count will be replaced with D. Count will get the input of D. Count will get the input of D. Okay, then else if E is equal to 1, then E is equal to 1. Here else if we are having E. If the E is equal to 1, it means these two conditions are not satisfied, and it goes to this one. E is equal to 1, then increment count value. We are in this stage. So increment count value mean count will be incremented by 1. Or in 4 decimal, it's 0, since it's a 4-bit counter, it's 0001. Count plus 0001. Else if it's not satisfied any conditions, there's no change, so we put null for that. End if Q will get the input of count, then end counter, and end behavioral. That's it. That's the final answer. I hope you guys find this video helpful. Thanks for watching. And if you are trying to learn digital logic design too, or if you are trying to learn VHDL language, there are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.